Good morning. Welcome to the penultimate week of grade 8. Awesome job this year so far. So, today we're going to look at rational numbers. Now, this is something you learned about last year. We're just going to get a little bit deeper with what a rational number is. So, my first two pictures I figured I'd show would be an irrational person and a rational person. We're going to cover irrational numbers over the next two classes. So if you remember from last year, we learned that a rational number is any number that can be written as a fraction with a numerator and denominator both as integers. And B, obviously, the denominator cannot be 0. So it can be written as a whole number, it can be written as a fraction, but you can also write it as a terminating decimal and as a repeating decimal. So a terminating decimal just means that the decimal points end. And then you have repeating decimals. And repeating decimals repeat the same digit or series of digits over and over and over again. So like 1/3, 0.33333333. So a terminating decimal, the way you know it's going to be terminating decimal if it's a fraction is if you can get the denominator to be a power of 10. Now, we didn't break anything down this year into prime factorization. The factors of the number are only 5 and 2. Okay, so for example, 4, I can get to have a denominator of a power of 10, and I can get it to 100 because what is the factors of 4? 2 and 2. 25 works because it's 5 times 5. 50 works because it's 2 times 5 times 5. Those are the only factors that can give me those numbers, so I can get those to be a power of 10. Let's look at the first one here. We want to turn this into a decimal. Now this is 25. I can get 25 to be a power of 10 pretty easily, simply by multiplying numerator and denominator by 4. That'll get my denominator to be 100, so 1 and 16 100ths. So that written as a fraction is 1.16. Now 5/33, if you look at the denominator, it's 33. The only factors of that are 3 and 11. I can't get those to be a power of 10. It's impossible. So this one is going to be a repeating decimal. And the way we do it is you just divide the numerator by the denominator. So the way I would write that is 0.15, and I put the line over everything that is repeating. So the 1/5 is consistently repeating. So it goes over both the 1 and the 5. Okay, 2/9. It's negative 2/9, but again, you just divide the numerator by the denominator. Now, there's a much easier way to do this than constantly doing the long division, and it is, let's use a calculator. So just do 2 divided by 9. What do I get? 0.2222222. So there's two ways you'll see this one written. You might see it written like this, with the line over the 2, or you might see it like this with a couple of 2's and then an ellipses, dot, dot, dot. Okay. Either one's correct. It just means that you're constantly repeating them. Okay, let's look at this one, 5, 6. Let's just use the calculator in lieu of time. So we're just going to do 5 divided by 6. If you notice, the first digit is 8, and then we have 3 being repeated here. So this is going to be 0.83, and then the line only goes over to 3. It doesn't go over all the other ones. Now we're going to look at how do you turn repeating decimals back into fractions. This is a little bbit more complicated. You've never done this one before. You know, if pretty much for the most part you've done like 0.333, you know, that's a thirds. And then you'll start to understand some of the other ones as you go through. But there's an actual way to calculate what the actual fraction is going to be with a repeating decimal. And that's what we're going to cover now. So the first thing you do is you write it as a variable equals that number. And now we know that this is really 25, 25, 25, 25, blah, 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 blah. We know that. So we're just going to keep it written like this. So what we do is we use what's called a power of 10. So powers of 10 are, now you did this in 5th grade, 10, 100, 1,000, 10,000, 100,000. And you can go the other way too, 10th, 100th, 1,000th. These are all powers of 10. So what we do is we multiply by a power of 10 where the exponent is the number of repeating decimals here. So how many digits do I have in my repeating decimal here? Well, 2, because the 25 is the repeat. So what I'm going to do is I'm going to multiply it by 10 to the second power, or 100. So each one of these gets multiplied by 100. So it's 100 times x and 100 times 1.25 repeated. So what is that going to equal? Well, this side is going to equal 100x. Well, everything here, if you remember doing this in 5th grade, everything just shifts 2 place values to the left. So the 1 goes to the hundreds place. This 2 goes to the tenths place. This 5 goes to the ones place. But then since there's an infinite number of repeating 0.25s after it, that just happens to stay there. So what are we going to do? Well, we're going to subtract the original equation. So we took it, multiplied it by 100, then we're going to subtract the original equation. So 100x minus x is pretty easy. That's just x. Here's where it seems a little strange. So the 125 minus 1 is pretty easy. That's 124. This part seems strange to you because you've never done that before, but think about it. This is an infinitely number of repeating 0.25. Here we have the same thing, 25, 25, 25, 25, 25, 25. So every time there's a 2, right underneath it, there's a 2. And every time there's a 5, right underneath it, there's a 5. So when I subtract this, that minus that, you guys remember this? Anytime you subtract anything by itself, you get 0. So I have 0 to the right of my decimal. To the left, I have 124. So I get 99x equals 124. Well, now I just solve it. 99x equals 124. Just divide by 99. And in this case, we're then going to simplify. We simplify the fraction, but we're also going to turn it into a mixed number. So 124 over 99 comes out to be 1 and 25 over 99. If you don't remember how to do that, don't you worry. We're going to do it now. Okay, so we have 0.888888. So we know that that's really 0.8 repeated. So we're going to first start it by writing it as x equals that number. Then we said we need to multiply by a power of 10. And we multiply by the power of 10 where the number of repeating digits we have. So how many repeating digits do we have? 1. So what power of 10 are we going to do? 1. 10 to the first. So both sides we're going to multiply by 10. All right. So this becomes 10x. This becomes, well, everything shifts one spot over to the left in the chart, in your place value chart. So this 8 goes to the ones. The 8 and the hundreds comes over and repeatedly have 8. So that's just where the bar is. Then we subtract the original from it. So that's 8 is equal to 0.8 repeating. So now 10x minus x is 9x. 8.8 repeating minus 0.8 repeating. Well, all these decimals are gone because each time there's an 8 on top, there's an 8 on the bottom. Well, that equals 0. So 9x equals 8. Oops, kind of ran out of room here. Divide by 9. X equals 8/9. And to prove it to you, let's go to the calculator. 8 divided by 9 is exactly what we just had. Kind of neat. Let's go to this one, 2.06. So x equals 2.06 repeating. So how many digits am I repeating here? I'm repeating 1. Okay, even though there's 2 digits after the decimal point, only one of these digits is repeating. So again, I'm going to multiply by 10 to the 1 power, or the first power. So 10x equals 10 times 2.06 repeating. So 10x equals, so everything here shifts 1 to the left, so 20.6, and then that 6 is repeating. Yes, I know it starts from there, but it's just going to make life easier if we just keep the repeat in the same location. So what did we then do? Subtract the original. So that equals 2.06 repeating. Let's subtract. 10x minus x is 9x. 20.66 repeating is 18.6. Divide by 9. So x equals 18.6 over 9. Okay. Not that big of a deal. Let's go and do some division. Okay, so we have x equals 18.6 over 9. This is going to seem a little strange, but it'll work. So what we need to do is, how many 9s can I get out of 18.6? So 18.6 ninths, I need to get wholes out of there. So that's 9 ninths plus 9 ninths plus 0.6 ninths, right? So if I add these up, I'm going to get 18.6 ninths. So that gives me 2, and now I have 0.6 over 9. That's a little strange, but that's okay. All we have to do is make them integers. So how do I get this to be an integer? Well, multiply numerator and denominator by 10. That'll get that to 6. That'll still be an integer, so that is 6 over 90. So 2 and 6/90ths. And to prove it to you, if I divide 6 by 90, I deleted that, add 2 to that, 2.06 repeated, and that's what our original equation was. Okay, let's try this one. So 0.64, so x equals 0.64 repeating. How many digits are repeating this time? This time we have 2. So we have to multiply by 10 to the second power, which is 100. So 100 times x gives me 100x. Then I do 100 times 0.6 far repeating. So this is still 100x. This is going to be 64.64 repeating. So now I subtract the original from that. You notice there's like lots of 9s and 99s and all that. It's just going to keep happening. So this will become 0.64 repeating. Subtract them, I get 99x. And then that equals 64. Because these 64 and those 0.64 keep repeatingly on, and they keep subtracting each other out. So now I divide both sides by 9 to 9. X equals 64.99. And put it in there. 64 divided by 99 is 0.646464 repeated. Okay, good luck today. Please reach out if you have any questions. Bye.